Good afternoon, ladies and gentlemen. Today, I would like to talk about the Bluetooth initiatives at LINE, and my name is Yohsuke Furuta. Nice to see you. The mission of LINE is closing the distance, and we're connecting various things and people so that the world can be more fun and more rich. And as part of that effort, we're also exerting our efforts in services that are more on the IoT side. And I am one of such engineers that are in charge of device connection services, and I serve as the technical lead in some of the projects, and I am a server-side engineer. However, I have been engaged in the core parts of IoT service, such as device specification development. In this session today, I would like to talk about the specific contents of such services, as well as the development philosophies behind certain products. And the key word here is Bluetooth today. To be more specific, this is the agenda. First, LINE Beacon is the service that I would like to explain. Some examples as well as protocols will be explained. And another is tappiness, the vending machine that is used in conjunction with LINE. I will introduce the tappiness as well as the architecture behind. And also, LINE Simple Beacon is another topic, which is a device that responds to LINE Beacon that you can actually develop specifications for on your own. So these are the main topics for today. First, LINE Beacon. LINE Beacon uses Bluetooth low energy technology, and it's provided together with the dedicated beacon device. It's a LINE platform business, but this might not explain so well what it is. So let me explain by way of introducing some of the introduction examples of LINE Beacon. This is an example of Tohan, which is a book distributor. Now, there are several hundred bookstores in which Tohan has installed LINE Beacon enabled devices, and there's a collaboration together with LINE manga or cartoon books. And when users come to a shop, the chat room will show this green banner, and you tap on it and you add friends. And then immediately the chat room will receive the manga or the comic, and about 10 titles are selected every month, and for free people can actually try reading the comic or manga, and the user reviews can be read as well. It's like a pop-up, the physical pop-up within the stores. So it's like a recommendation. Actually, this service doesn't end here. Once you're finished with the manga, you can get this dedicated sticker, and you also can apply for some kind of a lottery that you can win some prizes. So wherever the LINE Beacon is installed, the contents, limited contents can be shared only for those users that come to that store. And that really encourages people to want to go to physical stores. And next example is tappiness, which we do in collaboration with Kirin. Now, it's a payment system that uses LINE Beacon and Bluetooth LE, the bidirectional communication. And inside the vending machine, this device is embedded. For example, the user might choose a certain drink, beverage, and then that information, as well as the fact that was purchased, that information will be transferred using Bluetooth. And in this venue today, there are several tappiness vending machines. I'm sure that some of you have already tried using the vending machine, but let me just explain briefly how you're supposed to use that. First thing you need to do is launch Line, and then the backside of your smartphones, please put it against the vending machine. And then if you do that, like this picture shows, the screen will switch to tappiness dedicated screen. And so using Bluetooth, there is this connection established between your smartphone and the vending machine. And once that connection is established, then you can actually take the smartphone away from the vending machine. And then, as the text here says, it says here, please purchase the merchandise, and that's it. Of course, we would like to recommend Line Pay for payments. However, you can pay cash. In the actual tappiness vending machines, you can pay cash as well. And then the ticket for the beverage will come out. I will explain this later, but there's what's called the beverage coupon. So it's a ticket to get the beverage, and you can use it here. And using a specified payment method, the beverage will come out, as well as the vending machine itself will send you the points that you collect. And internally, it uses Bluetooth to notify the completion of payment, and application will receive this and does the right processing. And once you have 15 points collected, then the beverage coupon can be received in exchange for the 15 points. So I encourage you to use the tappiness machine as much as possible. So the two examples that I cited so far are both B2B. However, Line Beacon is not just a platform for those people or companies that are collaborating with Line. Actually, for general users, Line messaging API can be used, and in conjunction with that API, part of the platform is made available already. Well, what is messaging API in the first place? You might know this or heard about it in earlier sessions. In a nutshell, it's for bot developers. Line is providing messaging API as a service, and it's open to anybody that wishes to use it. A user that's following bot can receive a sticker, and that kind of event information will be sent to the bot server from the Line server using webhook. And in the case of using Line Beacon, the exact same method is used. A follower of bot comes closer to the beacon or gets away from the beacon, and the Line platform uses the webhook to send that kind of information to the bot server. So in a very simple manner, bot that is in collaboration with the beacon can be implemented. And this device that is responding to this is available in the market. And for example, Raspberry Pi can be used to develop your own. I will come back to this later. In such a way, the Line Beacon platform is leveraged in different services. I hope you understand that much so far. And therefore, now, I would like to now talk about the protocol that realizes this and what is the design philosophy, among others. So let me go a little deeper here. In Line, as I said, we use a dedicated device for beacon services. Now, we didn't start out by developing our own. For example, iBeacon and Eddystone were being considered as well. You might or might not know this, so I would like to explain this. Apple or Google are the ones that are have developed these specifications for the beacons, and they are intended to make beacon-related services to be easy to use. And Bluetooth energy is the, or Bluetooth low energy is the base technology, and the fixed data is to be advertised always. And so it's very simple in terms of implementation, and the hardware portion is just a generic Bluetooth equipment. So whether it is a mouse or keyboard, the hardware module that is used for those can be used as is. And therefore, the device can be manufactured at a low cost, so it's very efficient. And therefore, initially, we thought that we could use either iBeacon or Eddystone in providing our services, but at the end, we decided not to use them but develop our own method. The reason is the following. What we wanted to provide was a service that is really unique, something that can be provided only in that location. The business side or the business unit of LINE had long wanted to develop some kind of a service that is provided only to the people who walk into a store, a real physical store, a special kind of a coupon or stickers that are distributed to only those people who come to a certain location. However, security is important because you want to avoid spoofing and so on. And for iBeacon and Eddystone, that kind of application was outside their scopes, and therefore there was no specification to enhance security. Of course, you can combine various technologies so as to enhance security. However, the LINE application itself will end up being very complex, which we didn't want. We wanted to have this simple service provided for that particular location using the beacon. And so in order to realize that, we decided that we had to develop our own. And therefore, let me explain the approach that we employ in order to enhance the security level. So let me go deeper on that. Well, having said that, we're not doing anything that special. As you can see in this diagram, we have this secret key and timestamp for signature in the sent information and include that in the advertised data. And timestamp is included in the signature. Therefore, spoofing or replay attack becomes more difficult to do. And also, the logic for verification using secret key is done on the server side, which is safer. And therefore, even if the application itself is cracked, there's no worry of leakage of secret information or classified information. And what's important is additional information to avoid replay attacks in the advertised data. Now, security enhancement specification was missing in the other approaches I mentioned earlier. So let me explain that a little deeper. Now, this is the Eddystone packet format that's called UUID, and the applications, the purposes are already fixed in stone, so to speak, and there's no extra region where you can use for signature to enhance security. To be more specific, okay, the length is 31 bytes, and that's fixed. And in that 31 bytes preamble showing that it is Eddystone is included, and also namespace ID to identify the service, as well as color-coded beacon identification 6-byte region, and that's it. Now, 31 bytes is the total, and that's the limit. And that's based on the limitation coming from Bluetooth LE specification. In other words, there is no way of overcoming that. It's almost like the limited land of Japan as a country. You have this total land area or space limited, and iBeacon or Eddystone, whatever you use, you have to just share that limited amount of space, and that's really difficult to maneuver. And it's difficult for us to provide any flexible services with a lot of freedom. Therefore, we decided to develop our own protocol that is not so stringent. Now, we decided to develop our own protocol. However, within the framework of Bluetooth, how or what should we be careful about in trying to implement this in Bluetooth? I'm sure you wonder about that. Well, if I explain the details, it would take too much time, so I will just highlight what was difficult. Well, there are two key points that you need to keep in mind. One is broadcaster role, and you have to implement the device according to the broadcaster role. So you might ask me, what is broadcaster role? Actually, it's a name of the specification in Bluetooth. And it's really a specification for the device that just emits or sends out waves, the beacon, in a one-directional manner. And so it's like the data type that is to be emitted, or the rules pertaining to the constraints as to the intervals of sending out waves. And so iBeacon and Eddystone actually are designed according to this. And also UUID is to be used for identifying the beacon services. And so you have to predefine the UUID for the service, and beacon device is to advertise that, and the application side is to wait for that. Now, smartphone side has OS support, and for specific UUID, the application is to register a particular handler, and this transaction will take place properly. And this is close to the TCP/IP port as a concept. In other words, a UUID will be the basis for the matching once the OS receives the signal or the wave. So application doesn't have to process unnecessary data, and therefore the battery life can be extended accordingly. However, if you use the UUID as is, there is a problem. Because more than half of the packet available will be consumed by UUID, and that is a problem. I told you earlier, if you remember, Bluetooth having this maximum of 31 bytes, that's limitation. So of the 31 bytes, including UUID in that, what does that mean? Well, 31 byte itself is very small, and then that's further reduced to less than half. And so we wanted to have freedom, and that's why we selected our own approach. But UUID is a shackle. So what should we do? Well, we decided to use 16-bit UUID to compress the data.
So what is 16-bit UUID? This is a unique concept of Bluetooth. So standard UUID alias is 16-bit, and that is a 16-bit value. So it is simple equation like this, and you can convert the initial value. Using this, you can compress UUID so that you have more room in beacon packet, and you have more flexibility. So we wanted to use this. However, 16-bit UUID, if we use it freely, it would conflict with other services, or it would be in shortage. But there's no issue like that, because this value is not to be used freely. Bluetooth SIG, which is the standardization group for Bluetooth, we need to apply to SIG, and only when you get approval, you can use it. That is a rule. Of course, if you're going to use it, it's fine, but in order to issue it, you need the approval. In addition, you also have to pay $2,500. We pay this, of course, but this is not cheap. So in reality, not many people purchase this. So if you visit the website of Bluetooth SIG, you can see the list of who is using UUID. There are only about 244 at the moment. So for now, we don't see the issue of running short of this. So this is a capture of that page. Line beacon UUID is also listed here. And it takes about 1 month for registration. So if you want to use this kind of service, please have that time allocated in your planning as well for registration. So I talked about protocol design for line beacon, and now I would like to talk about technical aspects of tappiness. So as I mentioned earlier, tappiness is a vending machine connected to application, and it also provides payment service. When you want to provide this kind of payment service, what kind of architecture would you think about? Recently, IoT is a hot topic. So maybe you would think about vending machine connected to the internet. However, to connect the vending machine itself to the internet has many issues, and initial cost of installing the line is necessary, and also monthly maintenance cost is quite large. So this is a costly method. That is why what we thought of is not to connect the vending machine directly to the internet, but by using Bluetooth LE, Line app would become the relay point so that we can connect the vending machine to the internet at low cost. And I would like to explain about this configuration more in detail. In the center, there is the Bluetooth LE connection manager within Line application. This module controls the Bluetooth communication with the vending machine. And also, we export JavaScript API to in-app web. So the vending machine unique processing is described in in-app web using JavaScript. And of course, this is JavaScript in browser, so we can communicate with the server. So like this, the module within Line, the two modules are at the core to provide tappiness service. That is the architecture. So the screen here shows what is implemented using in-app web. So Bluetooth was the reference for us to implement this. So W3C currently is discussing the draft for a draft version of web Bluetooth. So from the website, you can connect with devices using this. By using this, we can connect to different kinds of devices, and this is applicable to many services. That is why we uniquely implemented a function that is very much like this web Bluetooth. When you swipe the smartphone to the vending machine, this is how you open the in-app web. And this is the inside story. So you would place Line device here. With that as the trigger to execute something, you need to monitor the wavelength strength, the wave strength, as well as adjustment of threshold is necessary. But this kind of UX adjustment can only be done using the actual device. So in the corner of our office, we implemented this test terminal, which was an empty vending machine. So from different angles, we conducted a test. And tappiness was known as a project only to limited members. So people who didn't know about tappiness looked at us in a strange way, saying that is a vending machine with no products inside. And those people they're using smartphone and in front of the empty vending machine. We attracted a lot of peculiar attention. So when you need to test with a vending machine, be careful not to attract such dubious attention. So lastly, let me talk about Line Simple Beacon. As I mentioned earlier, in Line, we have the beacon terminal with security features. And the detailed specs and system is not disclosed to the public. So users can only purchase the ready-made hardware. But some developers feel that that's not interesting. They want to create their own device. There are such people with high IoT capability, I'm sure. So please rest assured, for such rare people, we released the specification called Line Simple Beacon in February of this year. So using device that transmits Bluetooth, such as MacBook and Raspberry Pi, such devices can be used as Line Beacon. As I mentioned in the example earlier, by using messaging API of Line, bot developers can receive the events of followers getting close to the beacon through webhook. Line Simple Beacon as well uses this function. In addition to that, Line Beacon protocol design, I mentioned earlier that we are using 16-bit UUID to save the region within the packet. Ultimately, by using this in the small packet region, we were able to secure 13-byte open region. In the secure beacon specification, within this region, we also need to input the signature information for enhancement of security. But in Line Simple Beacon, this region is open to bot developers for their use. So developers can save any data they like in this region. This space is called device message. So you can put any data here. Not only that, but the contents here would be delivered to the bot server on webhook. So like the tappiness vending machine, connecting a device to the internet is quite difficult due to cost issues as well. So Line Simple Beacon allows sensor information of devices connected can be received through the Line platform on the cloud side. In any case, this can be implemented very easily and it is fun, so please do try this. So today I talked about Bluetooth initiative at Line. I talked about some case studies of Line Beacon and also to provide location-specified services. We developed the design of a secure protocol. And also, we have line-connected vending machine, tappiness. It's not connected directly to the internet, but we're using Bluetooth and Line as the relay to do the payment service. And I also talked about Line Simple Beacon, where you can create your own devices supporting beacon, so that various data on the device can be delivered to the server easily. That is all for my presentation, and I will be here until the reception later on. So if you're interested about Bluetooth or IoT, please come and talk to me. I'll be looking forward to talking to you. Thank you very much.